these are the notes on predicting products. You will want to have the notes available, and it will be helpful to have a periodic table. So our goals are writing balanced equations for chemical reactions. We have already learned how to identify the 5 types of chemical reactions and describing the components. And now what we're going to look at is how can we predict the outcome of a reaction based on the reactants. For writing out reactions, it's important we're able to write our ionic compounds. So creating compounds, we're going to just do a little review. So calcium iodide, this is a metal and a non-metal, meaning that this is an ionic compound, which means we need to use charges. So calcium, and I'm using my periodic table, has a +2 charge. And we can get that information here. Here's my calcium. That +2 charge is at the top there. So calcium has a +2 charge. Iodine, if we look, iodide means we're using iodine, has a -1 charge. And ionic compounds, because those electrons are getting transferred, every electron has to be able to move. And so both elements end up happy. And so we do our drop and switch, dropping the signs and then switching the values to the other element. So we're going to have a Ca1, we don't write the 1, I2 is calcium iodide. Sodium chloride, doing the same thing. I'm going to go to my periodic table. Again, sodium is a metal. Chlorine is a non-metal, so this is an ionic compound. I'm also not seeing any prefixes, so I can tell from the name as well. Sodium is Na. It has a +1 charge. Chloride is chlorine. That is a -1 charge. So when we do that drop and switch, drop the signs, switch the number, the value to the other element, we're going to have NaCl, 1 sodium and 1 chlorine. Carbon dioxide, well, carbon is a nonmetal, and oxide, oxygen, is also a nonmetal. So this is a covalent compound. So we're going to look at our prefixes, and our prefixes tell us how many of each we need. So carbon, there's no prefix. So if we have just the element with no prefix, that means we have 1 carbon when it's our first one. And then our second one, dioxide, that means that I'm going to have oxygens, and I'm going to have 2 of those for our covalents. All right. Another thing we just want to remember is our diatomic elements. As we are looking at reactions, if something is getting kicked out of a pair and it's by itself, we need to make sure we are acknowledging those diatomic elements. And when they are in their pure element form, they form molecules that consist of 2 atoms bonded together. There are 7 diatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And they will form those diatomics if they are alone. And we also have those labeled on our periodic table here. Down at the bottom is that kind of key, our diatomic elements. Any of those squares that have the stripes in them. So there are our first 6, and then hydrogen is also diatomic. And that's because those are so electronegative that they're going to pair with another like atom to form a molecule. And states of matter. We're also going to want to make sure we're indicating states of matter when our problem is asking us to. So S is for solid, L for liquid. This is only for pure liquids, so we're going to only see that for H2O in this class for water. G for gas, and then aqueous, a chemical that's dissolved in water. If we see the word aqueous or we see solution, then that is the state for that chemical that's been dissolved in water. All right, chemical equations, our reactants and our products. Our reactants are on the left side, the things that are doing the reacting. Our products are on the right side, the things that are produced. And so we're going to be predicting products. We're going to be predicting what is being produced in a reaction. All right, so we have our 5 types of reactions. Now we're going to go through how do we predict what we get. And if you understand and can recognize these reactions, now we're going to be able to understand what we have and predict what's going to happen. So a decomposition reaction is where one reactant breaks down into 2 or more simpler substances. So our examples, we have H2O, and that is breaking up. That hydrogen gets broken up from the oxygen in that decomposition reaction. So we can predict what chemicals we're going to get. That's what we're doing today. And then any of our balancing is going to come after the fact. And note, we have H2 and O2 because those two are diatomic elements. So when they're split from each other, then we're going to see those in that H2O2 molecule. FeCl2, that iron is going to split up from the chlorine. So then we have iron by itself, and then we have chlorine by itself, and chlorine is also diatomic, and so that's why we see that Cl2. So decomposition, one reactant breaking into 2 or more simpler parts. So how we predict the products, we break the reactants, which are on the left, the things that are reacting, into the simpler parts. We need to make sure we're paying attention to diatomics when we're splitting those up. So we've got 2HCl, aqueous. It doesn't matter what your state of matter is. We're going to just break these 2 up. So I'm going to have hydrogen by itself, and I'm going to have chlorine by itself. But I need to make sure, go and check my diatomic elements. If I go back to my periodic table, hydrogen is diatomic. Chlorine is also diatomic. So we're going to have H2Cl2. You don't need to predict the states of matter for that. All right, Na2S. We're going to separate out that sodium, separate it from the sulfur. It's just one of each unless they're diatomic. If we go to our periodic table, sodium is not diatomic. Sulfur is not diatomic. So we're going to just leave this as Na plus S. Any sort of balancing then, we would go back and do that afterwards. So if this is Na2S on the left, then we would put a 2 in front in order to make this a balanced reaction. ALN. So Al, again, looking for our capital letters to know where we're splitting. We're going to have aluminum and nitrogen. Aluminum is a metal. No metals are diatomic, but then we need to look at nitrogen. Is that diatomic? Going to your periodic table, and yes, nitrogen is diatomic. So then ALN is going to break up into Al plus N2. In order to balance, we would go and put, now we have 2 nitrogens on the right. So that means I'm going to need 2 of my ALN compound, which then means I would need 2 aluminums there. All right, synthesis reactions. These are the opposite of decomposition. So now we're combining the 2 reactants into one product. So taking those individual elements, and then we need to make sure we are writing a neutral compound when we put those together. All right, balancing charges to find our neutral compound. So Na plus S, sodium is a metal, sulfur is a nonmetal. So we're going to have sodium. I'm going to my periodic table and looking, and sodium has a +1 charge. Sulfur, going to my periodic table, has a -2 charge. So I'm going to drop and switch, drop the signs, switch what element it's on. And so my product is going to be Na2S1 or Na2S. In order to balance then, if I have 2 sodiums on the left, I would need a 2 in front of my Na on, if I have 2 sodiums on the right, I'm going to need a 2 in front to balance it on the left. Al plus Cl2, now we have aluminum, and it's going to join in a compound with chlorine. Aluminum has a +3 charge, using my periodic table. Chlorine has a -1 charge, doing our drop and switch. I'm going to have 1 aluminum and 3 chlorine, so AlCl3. In order to balance, this one's a little bit trickier. We have 3 chlorines and 2 chlorines. Well, the least common multiple, or to get those to be the same, I'm going to need a 2 in front over here. I'm going to need a 3 in front over here. Then that means I have 2 aluminum, so I would need a 2 here as well. All right, H2 plus Br2. Hydrogen and bromine are both diatomic, but once those are in a compound, that's not going to impact where we use our charges. We're not going to need to consider that they're diatomic when they're in a compound together. Hydrogen is a nonmetal, but it does have a +1 charge, so this is a little bit of a tricky one. Bromine is also a nonmetal, but it has a -1 charge, so that +1, -1, when we do our drop and switch, we're going to have HBr is that neutral compound. And in order to balance, we would have to put a 2 in front here. All right. So our third type of reaction, single displacement reactions. Since we're not putting two things together or breaking them apart, these ones get a little bit trickier. So a single displacement reaction is where one element replaces another element in a compound. And so one thing is getting switched out. And this is a pretty complex one in this example here, but you'll see fluorine is by itself here, and hydroxide, OH, is by itself here. So what's happening is that those two are switching places, single displacement or replacement. One thing is being replaced in a compound. So what we need to look at is the element that is on its own is going to switch with the same type of element. So we have aluminum, and aluminum is a metal, or it has a positive charge. And it's going to switch with whatever is a metal or has a positive charge. This is kind of a tricky one to start with. Our hydrogen also has a positive charge, so those are the ones that are going to switch. So aluminum was by itself. Now hydrogen is going to be by itself. We have to remember when we're switching things out, if we have one of those diatomics by itself, we need that H2. And then now that aluminum is going to pair with the chlorine, we have to make sure that that is a neutral compound. So now I know my aluminum and my chlorine are going to go together, so I'm going to need to look at my charges. Aluminum has a +3, chlorine has a -1. So when we do our drop and switch, we're going to have Al1Cl3 as that other product. All right, and going ahead and balancing, I have 1 aluminum on each side, 3 chlorines though on the right, so I would need a 3 here. Well, this is kind of a tricky one. But if I have 3 hydrogens here and 2 hydrogens here, let's skip balancing this one. I don't actually think your teacher is going to want you to balance it, but reach out to your teacher if you're not sure. You can't figure it out. That's a tricky one. All right, next one, single displacement. Sodium plus strontium hydroxide, and what is that going to produce? Well, sodium is a metal. It has a positive charge. Strontium is also a metal. It has a positive charge. So those two are going to switch. Sodium was by itself, so now strontium is going to be by itself. Metals are not diatomic, so we don't have to worry about that for strontium. And then my sodium now is going to have to pair up with my hydroxide. Sodium, using my periodic table, has a +1 charge. Hydroxide is one of my polyatomics. It has a -1 charge. So then we do our drop and switch, and we are going to have NaOH as that neutral compound. Going and balancing here, we have 2 hydroxides on the left, so I'm going to need a 2 here, and then I'm going to need a 2 in front of that sodium for a balanced reaction. All right, Ba plus HCl. We've got a metal, barium with a positive charge. We have hydrogen, which also has a positive charge. So those are going to flip. So we're going to have hydrogen by itself, and it is diatomic, H2. And then we have barium is going to be first, so barium is going to pair with chlorine. Barium has a +2 charge. Chlorine has a -1 charge. So we're going to have, doing our drop and switch, Ba1, Cl2. This one I think ends up being okay to balance because we just would need a 2 in front of our HCl. All right, fourth type of reaction is double displacement or double replacement. So now we're looking at we have 2 compounds and they're going to switch partners. So the 2 cation ions, which are the positive ions, switch places. So double displacement, we switch the cation ion in each compound. So we're switching each partner, and then we need to make sure each new pair is neutral by doing that drop and switch. So NaCl plus Ag2O. Now my Na is going to pair with my oxygen. So Na, sodium has a +1 charge. Oxygen has a -2 charge. So we're going to have Na2O. Then, even though it's in that second compound, our metal always goes first. So silver, Ag, silver always has a +1 charge, even though it's a transition metal. And then that's going to pair with chlorine. And chlorine is the nonmetal, so it's going to go second in that compound. So then we're going to do our drop and switch, 1 of each, so AgCl. And then we can go through, do any balancing based on how those compounds have changed the amounts that we have. I have 2 sodiums on the left, or on the right, excuse me. So I'm going to need a 2 in front here. Well, then that means I need 2 chlorines, so I need a 2 here. But then that means I need 2 silvers, but I already do. So that works out. So then that's balance. All right. SRI2, strontium iodide plus HCl, hydrochloric acid. So Sr has a positive charge and hydrogen also has a positive charge. So those are going to switch places. And so instead now my strontium, my Sr, is now going to get paired with the other element that has the opposite charge, that negative. So we're going to have Sr, which is +2, and then my Cl, which is a -1, drop and switch to make a neutral compound. So we're going to need Sr, Cl2 is our first product, and then my hydrogen, which has a positive charge, my iodine, which has a negative charge, those are going to form a compound. Hydrogen is going to go first because it has the positive charge. Chlorine or iodine has a -1 charge, so we're going to just have 1 of each when we do our drop and switch. So that's Hi. In order to balance, I have 2 iodines on the left. So 2 iodines on the left, I'm going to need a 2 here. Then that means I have 2 hydrogens, so I'm going to put a 2 here. But then that means I have 2 chlorines, and that works out because we already have 2 chlorines on the other side. All right, last one of these. NaNO3 plus KOH. When we have polyatomic ions, this doesn't change what we're doing. It just, instead of having just that nonmetal, we're just going to have that grouping is going to switch, that polyatomic. So my sodium has a positive charge, and my potassium has a positive charge, so those are going to switch partners. Sodium has a positive charge, hydroxide has a negative charge, so we're going to write that neutral compound. Sodium is a +1 from my periodic table. Looking at my polyatomic ion list, hydroxide is a -1. So when we do that drop and switch, we're going to have NaOH, 1 and 1. Then I've got my potassium, and it's going to now pair with my NO3. Even though potassium's listed second in our reactants, It's our metal, so it's going to be first in the compound. Potassium has a +1. NO3 has a -1. And so when we do our drop and switch, we're going to have KNO3. And that one is already balanced. 1 sodium on each side, 1 NO3 nitrate on each side, 1 potassium on each side, and 1 hydroxide on each side. All right, our last type of reaction is combustion reactions. Combustion is the burning of any substance in oxygen to produce CO2 plus and H2O, carbon dioxide and water. And so our fuel is going to be some hydrocarbon, carbon and hydrogen compound. So we're going to have to pay attention to our prefixes as if we are writing these out. But if we're just looking at predicting our products, this one, our products are always the same things. We always have CO2 gas and liquid water that get produced. And so our predicting ends up being pretty easy if we recognize this type of reaction. So our combustion reactions, if we have a CH compound and oxygen as reactants, so C3H8 plus O2, those are our reactants. Our products are always going to be CO2 and H2O. If we have, so this one we had C3H8 plus O2 gives us that CO2 plus H2O. If we have C2H6 plus O2, we have that carbon hydrogen compound plus oxygen. Notice oxygen's diatomic, which is why we see that as an O2. Well, what gets produced? CO2 and H2O. C7H2 plus O2, there's our carbon hydrogen compound. And then we have oxygen. Well, what is that going to produce? It's going to produce CO2 and H2O. I don't have enough room to balance, but you can then go ahead and balance these in order to get after you have predicted the products. All right, so practice, do you get it? We want to identify the type and predict the products. So things to look for is how many reactants do I start with? And that's going to kind of lend to how could this change? So this first one, NAF. Looking at this, I have just one reactant. And so the only thing that can change is that that's going to split apart. A split apart is a decomposition. So if we only have one reactant, the only thing that can change is separating. So this one's going to split apart. It's a decomposition reaction. And so we're going to get sodium by itself, and then we're going to get fluorine by itself. But with these, we need to make sure we're paying attention to our nonmetals. And if something is diatomic, we need to make sure that it is forming that molecule, that F2 molecule, which is how it exists in its pure state. And again, that's because it's so electronegative. All right, so those are my products. If I wanted to balance, I can. Feel free to balance that on your own if you'd like. All right, next one, lithium and sulfur. So I have two reactants, but they are lone elements. They're not compounds. So the only thing I can do to change this is to put those together, which is called synthesis. And so with those, lithium and sulfur, those are by themselves. That's how they exist as those neutral atoms. But when we put them together, we need to use their charges because lithium is a metal. It has a +1 charge. Sulfur is a nonmetal. It has a -2 charge. So we need to then look at their charges and drop and switch in order to write that neutral compound. So this is going to form Li2S. And then you can go ahead and balance if you would like. All right, third one, C10H20 plus O2. This one I have two reactants, but one of my reactants is that carbon hydrogen, and one of them is that O2. Having those as my reactants are a sign of a combustion reaction. And so if I can recognize that, my oxygen isn't going to switch out with anything. what this is going to do is it's going to form those products of CO2 plus H2O, which are always the products in a combustion reaction. All right, last three, identifying the type. So NaF plus CA3N2, well, I have two reactants and they are both compounds. So if I have two reactants and they're both compounds, well, the only thing that they can do is switch partners. And so this one is going to be double displacement or double replacement, double displacement, and those are going to have to switch how they're paired up. So my sodium has a positive charge, my calcium has a positive charge, so those are going to switch to be paired with the other element that has the opposite charge. So my sodium is going to get paired with that nitrogen that has a negative charge. So sodium, and I need to go to my periodic table to get what are the actual charges. Sodium has a +1 charge. Nitrogen has a -3 charge. So drop and switch, we're going to get Na3N. And then my second product, my calcium, which had that positive charge, is now going to get paired with my fluorine, which has a negative charge. Calcium is a +2 charge. Fluorine has a -1 charge. Drop and switch. So we're going to get CaF2. And then you can go ahead and balance. All right. Number 5, looking at what I have two reactants. One is a compound and one is a pure element. One is by itself. So the only thing that those can do is that our like element is going to switch partners. So with this, let's take a look at what we have. Lithium has a positive charge. Phosphorus has a negative charge. So we need to look at sulfur and decide, is that going to switch with phosphorus or with lithium? And sulfur has a negative charge. It's a nonmetal, meaning that it is going to switch with phosphorus. So now our sulfur is going to pair up with that lithium. So the phosphorus is going to get kicked out of the pair. It's going to be by itself. Phosphorus is not diatomic, so it's going to just be able to be a lone P. But then my lithium is going to pair with my sulfur because they have opposite charges. Lithium has a +1 charge. Sulfur has a -2 charge. So we end up with Li2S when we do our drop and switch. And then any other, and then we would need to go through and balance after the fact. So this one, I didn't actually say what it was. That one is single displacement. One thing is getting switched out of the compound. The thing that's by itself is getting switched in. All right, number 6, SR plus O2. We only have 5 types, so this one must be a repeat. I have 2 reactants. Neither of them are compounds, so it's 2 pure elements, 2 things that are already by themselves. So what's the only thing that can happen? They're going to form a compound. And so this one is going to be synthesis. They are going to get paired together. And so then we can look, and our SR has a positive charge, so it's going to go first in the compound. SR is a +2 charge. Oxygen is diatomic, which is why we have that O2 there, but when we're writing the compound, we need this -2, and then we can do our drop and switch. We don't need SR2O2 though. We're going to just be able to say SRO, one of each, and then we can balance as needed. All right, here's our rubric. We're looking at design and model in the patterns rubric for predicting those products. There is a worksheet, check your answers. There is a check-in for you to complete as well. Reach out to your teacher with any questions.